Okay, welcome students. This is part 2 of the session. This is a topic called implicit function. This is part 2. This is question number 2 which we are going to do now. Okay, I think I can see chat now. So if you have any doubts, you can ask me. Okay, so anyway, we are going to start this topic. Okay, this is sum number 2. Sum number 1 was previously done. Okay, so look at the question. We have question as xy plus y square equal to tan x plus y. It's not tan of x plus y, it's tan x plus y. So in this sum also you will not be able to make y as a subject. Kitna bhi try kar lo, you will never be able to make y as a subject. So what we are going to do is, at the back of our mind, you have to treat y as a nothing but function of x. Okay, so at the back of your mind, you have to treat y as a function of x. And how y square ka derivative is going to be the f of x ka derivative. F of x ka square ka derivative. So it's going to be 2 times f of x derivative of f of x. So keep that in mind. Okay, so now let us concentrate on this sum. Okay, I have xy plus y square equal to tan x plus y. Now what we are going to do is, we are going to differentiate with respect to x. We get derivative of xy, we are going to use UV rule here. So it's x times derivative of y, that is dy by dx, plus y times derivative of x, which is 1, plus derivative of y square is going to be 2y dy by dx equal to derivative of tan x plus derivative of y. So derivative of tan x is going to be sec square x plus derivative of y is dy by dx. So what you can do here is, you can take dy by dx common and you will get, so you bring all dy by dx term on one side and all non dy by dx term on the other side. So I'm going to bring this dy by dx on this side and I'm going to put this y alone on this side. So I will get x dy by dx plus 2y dy by dx minus dy by dx is equal to sec square x minus y. Now what you can do is, x plus 2y minus 1 times dy by dx is equal to sec square x minus y. Therefore, your dy by dx will turn out to be sec square x minus y the whole upon x plus 2y minus 1. And that's your final answer. Okay, let's go through once again. This is an implicit function because you cannot make y as a function, subject of the question here. So what we are going to do is, we are going to differentiate with respect to x by keeping y as a function of x in mind. Derivative of this is going to be UV rule, which is x derivative of y, which is dy by dx, plus y into derivative of x, plus derivative of y square is going to be 2y dy by dx. Derivative of tan x is going to be sec square x, and derivative of y is dy by dx. Now you have to bring all dy by dx term on one side and non dy by dx term on other side. So this one will come here, this one will go there. Finally dy by dx taken common and then divided, and that's your answer then. I'm starting with the question number 3 and 4 together. So first of all, look at the question, students. Please write this question in your notebook. I am going to do only one of them. I think I will do this one, fourth one. Okay, so let's see. The question here is, if sec of x plus y upon x minus y equal to a, where a is a constant, prove that your dy by dx is y by x. Second question is, if cos inverse of x square minus y square over x square plus y square is equal to sine inverse of a, prove that your dy by dx is y by x. So how do we go about? It's very simple. Okay, so I'm going to do this one. Now we are going to, there are three different ways of solving this sum, and I'm going to show you the easiest of all. Okay, in between I'll show you how one can proceed in between also. Please, one thing you have realized, that right hand side is a constant, and I'm going to make full use of that. As the right hand side is a constant, the derivative of that is going to become 0. So there is no point of keeping this cos inverse on this side. What you should do is, you take cos on both sides. So cos of cos inverse of this will simply become x square minus y square over x square plus y square will become cos of sine inverse of a, which is again a constant. Now one method says you can differentiate from here itself. So if you differentiate from here, you will be getting it as derivative of u upon v derivative of u minus u derivative of v upon v square is equal to 0. But let us take it one more step forward. What you can do here is x square minus y square upon x square plus y square is equal to b, where b is a constant, which is simply cos of sine inverse of a. One can rearrange this. X square plus y square is equal to b times x square plus b times y square. Bring all x square term together, y square term together, and what you should be getting it as 1 minus b times x square. So this was x square minus y square. Okay, correct. So you will get 1 minus b times of x square is equal to 1 plus b times y square. So finally you will get y square is equal to 1 minus b upon 1 plus b times x square, where 1 minus b over 1 plus b is equal to a constant called c. So we will get y square is equal to c times x square. And many of you must be figuring out, sir, you already made y as a subject. And yes, it's correct. So this type of questions in which initially it looks it is not possible to make y as a subject, but by doing a little bit of mathematics, little bit of trick here, you can make y as a subject. What we are going to do is, we are going to substitute here directly, differentiate it directly. So what will happen? What is derivative of y square? So derivative of y square will become 2y dy by dx is equal to c times derivative of x square is 2x. You can cancel 2, and therefore your dy by dx will become x by y into c. So what is the value of c? Don't say c is this. You substitute c in terms of the variable. Your c is simply y square by x square. So therefore your dy by dx will become x by y into y square by x square, and therefore your final answer is going to be y by x. Now what I suggest you kids, one can differentiate it from here itself directly and get this answer. One can make it into this form, and how we have got this answer here, that also is fine. So there are many other ways of solving this sum, but I think this is the cleanest of all. Okay, let us go through it once again. So what about this first sum? What you will do? Correct. You will take sec inverse on both sides, you will get x plus y over x minus y equal to sec inverse of a, which is a constant. You treat it as a b. Okay, I think that will be, I'll keep this one for homework. Okay, so just give a thumbs up if you are understanding, kids, because I am not able to see anything. Should I go ahead? Okay. Okay. So now we are going to do this sum. Okay. Yeah, got it. Okay, for the last step, what you should be doing is, Isha is asking this doubt. You need to replace the value of c, and c is y square by x square. So I'll resubstitute c as y square by x square, and then y getting cancelled, x getting cancelled, y by x. Okay, now come back to the question number 4. Okay, this is sum number 5 actually. Question number 3, you are going to do it at home, so therefore that's a homework sum. Now look at this question. I'll do this sum by 2 different methods. So let us see the traditional way of solving this sum. When you have a question as y is equal to x plus sine of a plus y, it's clearly not possible to make y as a subject here. So what you should be doing is treat y as a function of x and differentiate this. So let us see, we have y is equal to x sine of a plus y. Differentiating with respect to x, you will write that. What is derivative of y? dy by dx. And we are looking at now derivative of this into this. Clearly it is u into v rule here. So it's going to be u derivative of sine of a plus y plus sine of a plus y into derivative of x, which is 1. Let us write one more step. Therefore, your dy by dx will turn out to be x sine of a plus y ka derivative will become sine of something. LIFO लगाएंगे. So last function we have taken is sine. So we have to treat that first, which is cos of a plus y into derivative of a plus y. Derivative of a is constant as it is. A is a z constant. Its derivative is going to become 0. And derivative of y is going to be 1 times dy by dx plus sine of a plus y. So now what we should be doing here is very simple. Bring this term, which is x cos of a plus y times dy by dx on one side. Correct? That's the objective, because our objective is to find dy by dx. So if I bring that on the other side, I'll get dy by dx times 1 minus x cos of a plus y. I brought this term on the other side and taken dy by dx common, is equal to simply sine of a plus y. So what you will get, your dy by dx is going to be sine of a plus y over 1 minus x cos of a plus y. And that's the answer. Oh my god, that's not the answer. See, when you see the answer we require sine square of a plus y, sine of a plus y, y cos of a plus. Oh my god. And we are nowhere close to that. But what you realize, that answer do not have any x term. So how do we get rid of that? How do we get rid of this x term? So what you should be doing here is, go back to the question. What is x equal to from here? Your x equal to Hand is shaky a little bit. I need a stand, I believe. Okay. Okay. So what you should be doing here is, you can make x as a subject as x is nothing but y upon sine of a plus y. Resubstitute that here. So when you do that, you are going to get sine of a plus y over 1 minus y upon sine of a plus y into cos of a plus y. When you take LCM, you will get sine square of a plus y over sine of a plus y minus y times cos of a plus y. And that's what we wanted. Is there any doubt? Let me know. I'll just go through it once again. Your question was y is equal to x sine of a plus y, and I have to prove something like this. So you will differentiate with respect to x directly. So y ka derivative is going to be dy by dx, and here it is going to become UV rule, which is x times derivative of sine of a plus y, sine of a plus y derivative of x, which is 1. Now how do you take derivative of sine of a plus y? So if you understand the LIFO, sine of a plus y ka derivative will become cos of a plus y into derivative of a plus y, which is derivative of a is 0 and derivative of y is dy by dx. Now bring this guy on the other side. And if you take it on this guy on the other side and take dy by dx common, you get dy by dx equal to 1 minus x cos of a plus y is equal to sine of a plus y. So dy by dx is going to become sine of a plus y over 1 minus x cos of a plus y, and hence after taking LCM you will get the answer. You need to replace the value of x. So x is nothing but y over sine of a plus y. So you need to substitute x as nothing but y over sine of a plus y. And hence after taking LCM, this is the answer there. Fair enough, kids? Give a thumbs up if you understood this second sum. Okay, I hope you are writing everything. Okay, I'm going to send you the snap of the questions later on WhatsApp. Okay, I do see only 44 students online, so that's not fair. Okay, kids. So now what we are going to do is we are going ahead for, sorry, I think I missed something here. Okay, so now I am going to do, this was a traditional way of solving this sum. Now little thoda hatke karenge. Now what we are going to do is we are going to differentiate, we are going to prove this by another method. Clearly, when you look at the question, you cannot make y as a subject. You cannot make y as a subject, but you can make x as a subject. Yes. So we find x as a subject, find dx by dy and reciprocate the answer. Say for example, if you make x as a subject, I will get x equal to y over sine of a plus y. Now if you use dx by dy, that is differentiating with respect to y, and not x. Okay, so derivative of x will become dx by dy, and here you have to use u upon v rule, which is v derivative of y with respect to y is 1 minus y derivative of sine of a plus y is going to be cos of a plus y into derivative of a plus y, which is 1 over sine square of a plus y. Therefore, your dy by dx is simply mere reciprocal of this, which is sine square of a plus y over sine of a plus y minus y cos of a plus y. Much simpler way. But here we are using the concept that dy by dx is a reciprocal of dx by dy. Okay, so that's an easier way to prove the same sum. And now we are going for the sum number 6. Okay, so here is the question. If sin x equal to y times sine of x plus a, prove that sine a over sine square of x plus a. Okay, Dev, I'll give you a break sometime later. Okay, so sine of x equal to y times sine of x plus a. So in this sum, it is very clear, this is very basic level sum, because you can make y as a subject very easily. So what we'll do is y is equal to sine x over sine of x plus a, and after using u upon v rule, you will be able to get this answer. Thoda hatke hain, that is dy by dx is going to be v derivative of sine x is cos x minus sine x derivative of sine of x plus a, which is cos of x plus a, into derivative of x plus a, which is 1, the whole upon sine square of x plus a. And that's the answer. No, that's not the answer. Answer is simply sine a on top. Have you realized this? This is nothing but sine a cos b minus cos a sine b. So that can be written as sine of a plus b minus b over sine square of x plus a. X will get cancelled. So your dy by dx will become sine a over sine square of x plus a. That's the answer there. Okay. So this was very simple. This was very basic sum because it is possible to make y as a subject. So वो झंझट करने का जरूरत नहीं. You just make y as a subject, find dy by dx and get the answer there. Fair enough. We are going ahead. Next question. Okay, kids. I want you to try this on your own. Okay. The question is, if sine y is equal to x sine of a plus y, prove that dy by dx equal to sine square of a plus y over sine a. How many of you think that we should make y as a subject here? No, sir, y cannot be made a subject here. But clearly, last time in the sum number this is sum number 6. This is sum number 7. Okay. So in sum number 5, I showed you there are two ways to do this sum. So method 1 is going to be simply differentiate this directly by using UV rule here and then get the answer. Or method 2, which I showed you, is make x as a subject, which is simply sine y over sine of a plus y. Differentiate this, okay, with respect to y. I will get dx by dy is equal to v derivative of sine y with respect to y is going to be simply cos y minus sine y derivative of sine of a plus y is cos of a plus y, the whole upon sine square of a plus y. Now what you should be doing here is simply look at the numerator. Sine A cos B minus cos A sine B is simply sine of A minus B over sine square of A plus Y. Y getting cancelled, you will get simply sine A over sine square of A plus Y. This is your dy by dx, and therefore this is dx by dy, and therefore dy by dx is simply reciprocal of that, which is sine square of A plus Y over sine A. Okay, I think kids. Okay kids, so this is what the implicit function is all about. We are going to do the questions on this. I will send you the photocopy of the textbook exercise 5.8 ML Agarwal, and you have to send me the homework on this on as a PDF. Don't send me as an individual pic. You will do the homework. I'll mark the sums and you will do the homework. Okay. I think that's enough for the day. Okay. Bye kids.